The objective today is to explain what measurements are used to determine the quality of service in a network. So the first line of Wikipedia basically says that QoS is the description or measurement of the overall performance of a service, such as telephony or computer network or a cloud computing service. And this is particularly the performance seen by the users of the network, so it's on the user side. Though I don't know what the difference would be if we're talking maybe server side or something. But to quantitatively measure quality of service, there are several related aspects of the network service to consider, such as packet loss, bit rate, throughput, transmission delay, availability, jitter, etc. So in the field of computer networking and other packet-switched communication networks, the quality of service refers to a traffic prioritization and resource reservation, rather than the achieved service of quality. So if we're talking QoS, we care more about prioritization being established and the availability of particular resources that we've reserved. So the quality of service is the ability to provide different priority to different applications, users, or data flows, or to guarantee a certain level of performance to a data flow. And during one of these exhausted, like Friday complaint sessions I find myself in once in a while, I brought up the relation of this word configuration to the word settings. And the person who was listening to me actually put this beautifully. They said that you configure a system with specific settings. So yes, these words are very similar. And to just remember the difference between a configuration and a setting, just think that configure is like the verb and the setting is the noun. It's the thing that you are configuring. Now, another similar confusing word is this word provisioning. So provisioning means to allocate resources to a specific need. This makes sense in the context of resource reservation. And if you want to improve the quality of service, maybe a particular service such as telephones must always have the ability to immediately call out, so therefore you might provision a data flow line for that particular service. And speaking of the field of telephony, quality of service was defined by the ITU in 1994. This is an interesting organization. If you have free time, research it more. But it says quality of service comprises requirements on all aspects of a connection. But the way this organization is defining quality of service is they're looking at multiple aspects of connections. And they're saying things like a service response time needs to be at a certain level, the loss, the signal to noise ratio, crosstalk, echo, interrupts, frequency response, loudness level, and so on. These are the types of things we look at to analyze the quality of service for telephones, or at least the ability to communicate through telephones. Now, originally, this ITU, the International Telegraph Union, was a specialized agency of the United Nations that was responsible for issues that concern information and communication technologies. The ITU coordinates the shared global use of the radio spectrum, promotes international cooperation in assigning satellite orbits, works to improve telecommunication infrastructure in the developing world, and assists in the development and coordination of worldwide technical standards. Just a fascinating organization. And if you have time, it'd be worth it to research them. But let me go even farther and go to a super high level of information here that you don't necessarily need when you're studying quality of service. But I want you to know that a network or protocol that supports QoS may agree on a traffic contract with the application software and reserve capacity in the network nodes. For example, during a session establishment phase. Now, during the session, it may monitor the achieved level of performance, and the example is the data rate and delay. So after monitoring this, the application may dynamically control scheduling priorities in the network nodes. Think back to our lesson on unified communications. This application may release the reserved capacity during something called a teardown phase. And in this networking class I teach, we talk about protocols so much, it would be worth your time to learn the protocols for quality of service, or at least the protocols we can use to establish better qualities of service. So here's a non-example. When understanding something new, it's sometimes nice to see a non-example. It says that a best effort network or service does not support a quality of service. So the non-example of QoS is best effort. We could have this established and prioritized system to provide communication services, or we could just over-provision the capacity so that it is sufficient for the expected peak traffic load. Now, the resulting absence of network congestion reduces or eliminates the need for quality of service mechanisms because there's just not a lot of traffic to worry about in the first place. So when I think of best effort, I think of this guy from the Two Stupid Dogs cartoon where he sees something being done, but it's done wrong. Best effort is looking at the worst case scenario in terms of traffic and then just trying to prepare for that even if it rarely happens. An example of this would be the Postal Service. They deliver letters using a best effort delivery approach, and the delivery of a certain letter is not scheduled in advance. There are no resources pre-allocated to the post office. The service will just make their best effort to try to deliver a message. Makes sense that their peak hours would be maybe around Christmas time, but even then, we've all probably experienced delays in the post office delivering letters. And on top of that, the person who sent the letter is not necessarily informed if the letter has been delivered successfully. I mean, you would need to go through some sort of tracking system. So maybe like UPS or FedEx would be an example of a quality of service example instead of this best effort that the Postal Service gives us. Now, another way to do things would be called circuit switching. And my horrible joke here is switch circuiting, as in you're switching the circuit switching word. But this example is how telephone networks work. They work by using circuit switching structures. That means during the connection phase of a new phone call, resources are reserved for that connection to stay open. And in the olden days, you might find yourself with a busy signal when you called somebody who was on the phone. And that signal was informing the user that the call is blocked due to a lack of capacity. An ongoing phone call can never be interrupted due to overloading of the network, and it's guaranteed this constant bandwidth. However, nowadays we are experiencing dropped phone calls, which is funny because it never happens with a landline. Which says the Internet Protocol offers a best effort service of delivering datagrams between hosts. So basically delivering the internet to people. IPv4 is a connectionless internet protocol that depends on the best effort delivery approach. IPv4 datagrams may be lost, arbitrarily delayed, corrupted, or duplicated. The applications built on top of it implements the additional services they require on an end-to-end basis. So it sounds like depending on the application, we could move from best effort approaches to other approaches. And we would look at TCP and UDP as our examples. It says that the transmission control protocol provides a guaranteed delivery of an octet stream. Okay, why do they say that? It is just a bit stream. It is just the data that we talk about being sent over the internet all the time. So TCP is nice because it provides this guarantee of a delivery between a pair of hosts to the above layer, that is the IP layer, and it is internally splitting the stream into packets and resending these when they're lost or corrupted. And this is in contrast to what's called the user datagram protocol. UDP provides a thinner abstraction layer which only error checks the datagram. So when the UDP packet gets sent, there's a way to make sure that data is still intact, but there's not a way to make sure that the data ever reached its destination. Both of these are called transport layer protocols and provide what's called multiplexing between processes. Multiplexing is a fancy word for you can send and receive. So one of these is a great example of a best effort approach, and the other is an example of a circuit switching approach. Now, when you offer a quality of service to one of these approaches, what you're doing is you're prioritizing certain types of data or uses. And I just keep going back to my phone call example of like the idea that if somebody needs to call 911, that has to be of the highest priority. Or maybe less extreme, if I'm a person who works at a company and I'm on a phone call, I don't want that phone call to be dropped. However, if a person in that company is watching a video for whatever reason, maybe they're researching how to solve a problem, so it may be a legitimate video they're watching, that video still needs to be lower in the list of priorities. They have to sit there while it buffers a little bit. That should not be a big deal. So the frustration comes from a inappropriate configuration inside of that network. And so quality of service is sometimes used as a quality measure. Many alternative definitions. This was a hard lesson for me to teach. The ability to reserve resources is a bit of a different idea. I want you to think of quality of service being a reference to the guaranteedness of particular services, but don't confuse QoS with the ability to provide high performance. In that case, you just use the word performance for your network. Does the network have a high bit rate, a low latency, and or a low bit error rate? So for the last time here, in your own words, what is quality of service? Now, QoS is sometimes used in application layer services such as telephony and streaming video to describe a metric that reflects or predicts the subjectively experienced quality. Here's another non-example for you. So I want to use the word QoS in my networking class to refer to networking things, not application layer things. And in this context, QoS is the acceptable cumulative effect on subscriber satisfaction of all imperfections affecting the service. And other terms with similar meanings are the quality of experience, mean opinion score, perceptual speech quality measure, and perceptual evaluation of video quality. So my joke here is don't be selfish and start using QoS to describe your subjective opinion of your network performance. If you want to talk about those things, you have all these other terms to go ahead and use. So let me end this lesson by just reminding you of all the types of traffic we might see. We have streaming types, so we're talking television, maybe radio kind of stuff, audio over Ethernet, or something called audio over IP. You have VoIP, that's voice over IP. If you're in my classroom, I have a telephone that uses an Ethernet cable instead of one of those DSL cables, those telephone cables that many people are used to seeing. And that just means that when I use my phone, I'm having an IP address associated to that phone. Other video streaming, other data that we might see on a network include video telephony, something called telepresence. If you have storage stuff going on in a network, such as ISCSI or Fiber C, something called circuit emulation service, safety critical applications such as, and then it kind of cuts off over here. But for the rest of these, I just wanted you to kind of take your eyes and really focus on a few of them in red here. So online gaming will be a hit in my class. So that's a type of streaming. An interesting one, though, was industrial control systems. I wonder if an example of that would be like my ability to, from my cell phone, change the temperature of my classroom, or an industrial like warehouse, maybe changing temperature or changing something else about that warehouse. And I just want you to think of all these examples here. Which three would you like prioritize in your home? If your home's like mine, I can change the temperature from my bedroom from my cell phone, which is helpful particularly early in the morning when it's like freezing cold. I don't want to get out of the blankets. I just turn the heat up and wait a little while. So that's the type of traffic going on in my house. You tell me about yours there. And for our last slide, let's just talk about security real quick. Strong cryptographic network protocols such as Secure Sockets Layer, that's SSL. My students study the newest version of SSL called TOS in class, and we study that byte, which is pretty cool. Another security protocol is I2P. I don't know much about that one. And then you have your virtual private networks, and these obscure the data transfer using them. So as you can imagine, immediately after reading that sentence, that quality of service will be difficult to do if it's hard to prioritize things that you don't know what they are because they're cryptographically hidden. Not to mention that when you cryptographically hide something, that's going to take sometimes more data. For some organizations, this can be an unacceptable thing, maybe even a hazard. So if your quality of service approach involves doing a deep packet inspection, you might be in trouble. So just because I'm a huge fan of reading RFCs, here are a few that will mention quality of service, so I'll try to create some videos on that in the future. And that's the end of the lesson. So here's your DOL. How can a business or organization measure quality of service, and why would they want to do so?